So essentially, we started out with a simple example of finding the price of a house. Towards that, we sort of collected what is known as features, and we wanted to find the function that maps features to a number called the price, right? So the other assumption that we made, typical assumption that people make is, for example, the relationship between the price and the features is linear. So you can just assume that y is w1, x1, and so on. And you add an error term, which is the model error, right? For example, it need not be linear. It can be, let's say, second order polynomial. Then this noise will capture that difference. Okay, then in general, suppose if f is the function, how do you find this function f based on the data? So you collected the data and then figured out, so the way to figure out what f is through this equation, right? This particular problem, right? You minimize over all possible functions, that you minimize the squared error with respect to all possible function f, right? And this is a very complicated problem. Therefore, you use certain assumptions on f. So this sort of motivates optimization problem. You need to solve optimization problem in many situation in data science, many cases in data science. The second problem that we looked at was matrix completion. So movie rating problem, where it turned out that a suitable problem to solve is minimize what is called rank of a matrix, subjected to the constraint that wherever you have entered, the people have entered the rating, it should match, right? Wherever you haven't entered, you should be able to figure out that those values. Okay, so essentially, this motivates not only optimization but also linear algebra, right? So you need to know what rank is. You need to know how do you minimize what kind of a function is rank, and so on. Okay, so the third example that we looked at was spam versus non-spam problem. So essentially, there is an incoming email, and you have to figure out whether it's spam or non-spam in an automatic fashion. So what you do is you remove all unnecessary words like articles like an, a, and so on. And then you have a bag of words called dictionary, and you count the number of times each word in this bag of words appear, right? That you call it as feature vector here, x1 through xk. Okay, so now the problem is, the problem boils down to, given this feature vector, you have to say whether it's +1 or -1, right? Spam or non-spam. Okay, so the other important thing to observe is these data are getting generated in a random fashion, because beforehand you don't know what kind of data will appear. So a nice model for that is probabilistic or stochastic, right? So you can assume that these data are generated according to some probability distribution. So probability theory is in fact at the core of mathematics for data science, which is something that we don't study in this particular course. You have already studied, and there is one more course in the next semester called stochastic processes, which you will end up taking, wherein we will study much more than the first course in probability theory.